Swayam Prabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. In the last class we were looking at the boundary conditions and we came up with this Kirchhoff effective resultants of the first and second kind, and we were explaining the resulting boundary conditions. Okay. So now, just as an example, if suppose an alpha 1, this is an alpha 1 direction, so an alpha 1 edge suppose is free, this free edge, okay, then what would happen? You would have n11, this is n11, that is 0, okay, then you will have m11, the moment resultant 0, and then the vertical shear resultant 0, okay, and lastly the other shear resultant 0, that is a free edge. Okay. Similarly, if it was clamped, suppose it was clamped, so this is free. Suppose it is clamped, held, okay, like a cantilever beam, end of a cantilever beam, then you will have u1 0, you will have u2 0, you will have u3 also 0, and then you will have beta 1 equal to 0. Okay. So that's how the boundary conditions end up. Okay. Now what I am going to do is this: after a lot of mathematics we have come up with 5 equations of motion. Okay, and at this point we do not know physically what each of these terms mean, right, a bunch of terms, so it is confusing. Okay. So what I want to do now is take a spherical shell. Okay, I will take a spherical shell. Okay, so both R1 and R2, are equal to R. How do you get a spherical shell? You have an axis, it's a surface of revolution. I take a meridian. Okay, what is the radius of curvature of the meridian? R. This is R. Then I rotate it around this axis, I get a sphere. Okay, then any normal to this intersects the axis where? At R. Okay, that is the second radius. Okay. For example, for the cylinder what happened? We had an axis and a straight line. Okay, that straight line is the meridian. Its own radius of curvature is infinity. Then it revolves, it goes around this axis and it generates the cylindrical shell of revolution. Then the intersection of this with the axis is your second radius of curvature. R2 is A. So by that logic, for a sphere, R1 and R2 are both equal to R. R is the radius of the sphere. Okay. So now if I have a sphere, okay, and I have a sphere, let's say, and I take, this is my center, suppose, then at some point I take an element on the sphere, this is an element on the sphere. Okay, so what I'll do is elevation angle here will be phi, whereas the azimuthal angle, okay, will be theta. Okay, the phi is the elevation angle, and theta is the azimuthal angle. This will be alpha 1, this will be alpha 2. Okay, now my first equation of motion, that is in the alpha 1 direction, okay, that means will be in the phi direction, is given by minus del alpha 1 N11 A2. Okay, that is the first term. The second term is minus del alpha 2 N21 A1. Third term is minus N12 del A1 by del alpha 2. Fourth is plus N22 del A2 by del alpha 1. Next is minus A1 A2 Q13 by R1. The signs are consistent, that's all. Okay, plus A1 A2 rho H U1 double dot is equal to the force Q1. Okay, this is the most general alpha 1 equation. So let's look at each of these terms. So in the spherical coordinate, okay, more is required, I suppose. Okay, so we have given R1 is equal to R2 is equal to R. Okay, so now if I look at my spherical shell and I have an element on the surface, and this is my phi, let's say this is my phi, and this is my d phi, a little bit exaggerated. Okay, so now this, what is the length element for that? Okay, along theta direction, what is the length element? Okay, so the angular change is d theta. Okay, but you need something to make that a length, make this edge a length, make this a length. So that would be what? This, right? So if you look at it from the top, that looks like a pie. Okay, this is this edge over here, which is d theta. So I need this length. I need this length. Okay, so that would be what? This is my radius of the sphere, and I need this length over here. If I change color, I need this length. So that is r sin phi. This length is r cos phi. So that length is r sin phi. So r sin phi d theta is this elemental length. Okay, what is this elemental length? By this time there is a d phi increment, so it is r sin phi plus d phi. D theta remains the same. Okay, so that means my A2, okay, A2 is equal to r sin phi. A2 converts alpha 2 into a, or d alpha 2 into a length. Okay, A2 converts d alpha 2 into a length. So this is r sin phi d theta, whereas this length is simply r times d phi. Therefore A1 is equal to r. Okay, so that A1 d alpha 1 is equal to r d phi. So let us remember, A1 is equal to r, A2 is equal to r sin phi. Okay, and therefore if I write the first equation, in alpha 1 or phi direction by changing the sign, okay, then I get del phi n phi into r sin phi plus del theta n theta phi. A1 is r plus n phi theta del theta A1 is r plus n theta theta del phi of A2, which is r sin phi, minus A1 A2, which is r square sin phi q13, which is q phi 3 by r1 is r, the first term, and theta phi is the second term, then n phi theta is the third term, then this is actually the fourth term, n theta theta is the fourth term, then q phi 3. So if I switch the sign, that is equal to a plus, this will be a minus, this will be a minus, the others will be plus. Okay, so this is a plus, that will be equal to r square sin phi rho h u phi double dot. For the moment we kept the force out of the picture. Okay. So what we now have is 1, 2, 3, 4, 5 terms. Okay. So we'll look at these 5 terms. Okay. So the first term. Okay. So we have, let me draw the big element. Okay. So here is my, let's say, axis. So this angle is phi. It's exaggerated, so this is my d phi. Okay, and so this is the phi direction, this is the theta direction. Okay, so now I have n phi phi, okay, n phi phi, force resultant, okay, and n phi phi plus del n phi phi del phi d phi is also a force resultant. Okay. So now let us say we keep our local coordinate right at the center. Okay. So now we are going to match forces in the phi direction. This is my positive phi direction. Okay. So what is the positive expression? It is okay, what is the negative? What is this term? First of all, it is minus n phi phi, and it has to be made into a force. So the force is r sin phi d theta. Okay, this length, and phi phi into that length. So that length now is r sin phi into d theta. Okay. Now the incremented side I have plus n phi phi plus del n phi phi by del phi d phi, but now even the length is incremented. Okay. So why? Because the basic A2 is r sin phi, but here it is r sin phi plus d phi. So we have r sin phi plus d phi d theta. Okay, so we have to expand this. So let's see, I have minus n phi phi r sin phi d theta plus n phi phi plus del n phi phi del phi d phi, okay, into sine of phi cos d phi is 1 we will take, plus cos phi and sine d phi we take it as d phi r d theta. So this is equal to minus n phi phi r sin phi d theta plus, you open the brackets, n phi phi sin phi r d theta plus n phi phi cos phi d phi r d theta plus del phi of n phi phi d phi sin phi r d theta, the last term del n phi phi del phi d phi cos phi d phi r d theta. Now this term and this term will cancel out, so we take them out. Okay, and here we have a differential d phi, a differential d theta. Here we have a differential d phi, a differential d theta. Here we have a differential d phi, another differential d phi, another differential d theta. So we will ignore this term as it's one order smaller. Okay, so that leaves me with what? N phi phi cos phi r d phi d theta plus del phi n phi phi sin phi r d phi d theta. Okay, so you can see here this is the same term, okay, minus the d theta d phi. Okay, so this term ends up exactly as this term minus the d phi d theta. So that's the first term. Okay, the second term. Let us see how the second term comes up. Okay, the second term is n theta phi. Okay, let me write it on the other side. Del theta n theta phi into r. Okay, so if we again draw our element, this is my axis, this is my phi, this is r, this is d phi. Okay, n theta phi is on the phi theta face, in the phi direction, this and this. Okay, so this is n theta phi and that is n theta phi plus del theta n theta phi d theta. Okay, I am incrementing my theta this way, I am incrementing my phi this way. Okay, so now we have to add the forces in the phi direction. This is the phi direction. Okay, so what happens? The negative side minus n theta phi, it is still a force resultant. Okay, then what? Then we make it a force by doing r d phi, that is the length of this element. That's the length of this element. Okay, so now it's a full force plus the other side n theta phi plus del n theta phi del theta d theta is the force resultant, again into r d phi. Okay, so this first term will cancel out, and I will end up with del theta n theta phi into r, and outside I have d theta d phi. So it's exactly that term. Okay. Next, the third term. Okay, if you look at the third term, it is n phi theta del r del theta. Okay, and so we will set it to 0 because r is not changing with theta. So for this geometry, this is 0. Okay, the next term, the fourth term is n theta theta del phi of r sin phi. So let's see. Let me write it first. Minus del theta, minus n theta theta minus n theta theta del phi of r sin phi. Okay, so now let me see if let me separate it out first. So this is the earlier term. So now let me again draw the element. So I have this is my phi, this is d phi. Okay, now n theta theta is like this. Okay, it's on the theta faces, it's a normal force resultant. Okay, it's a normal force resultant. So if we look at it from the top, okay, looks like this. It looks like this from the top. So this edge is this edge, this edge is this edge, and n theta theta is coming out like this, n theta theta is coming out like this. Okay, so on the left side it is n theta theta, on the right it is n theta theta plus del n theta theta del theta d theta. Okay, and I have to compute the force in the phi direction. So this is the phi direction, right? That is the phi direction. So I'll have this thing has a component this way and this way. It has a component, vertical component. So I have to compute the vertical component of this thing. Okay, so now if I consider, so this angle to be, let's say, alpha. Okay, then this angle is alpha, then this angle is alpha, this angle is alpha, and it is a small angle. Similarly, this angle is alpha, it is a small angle. Okay, So I need sine alpha of this thing. I need a sine alpha of this quantity. I need a sine alpha of this quantity. Okay, so what is alpha? So this length now is r times sine of phi plus d phi d theta. Okay, so the difference, so the top is r sine phi d theta, and the lower is r sine phi plus d phi d theta, which is equal to r sine phi cos d phi is 1 plus cos phi sine d phi is d phi into d theta. So the difference between these two is r cos phi d phi d theta. Okay, so that is the difference. Then I need half of that. The difference is this plus this. I need half of that. So I need half of this. Okay, that is this. Okay, now that divided by this, which is r d phi. R d phi, okay, is equal to tan alpha. Is that okay? So if I cancel out, tan alpha is equal to cos phi d theta by 2. Okay, for small values of alpha, tan alpha is equal to sine alpha is equal to alpha. Okay, so now what do I have? I have n theta theta into sine alpha, which is cos phi d theta by 2. Okay, and from here also plus n theta theta plus del n theta theta. Hold on, just hold on 1 second, let me go back. So first is n theta theta, this one. I have to make it a force. It is made a force by multiplying with r d phi. Okay, this length is r d phi. This length is r d phi. Okay, for small values of alpha, this is also r d phi. Okay, so now it's a force. Then sine alpha, which is cos phi d theta by 2, plus same thing, n theta theta plus del n theta theta by del theta d theta, again sine alpha, which is cos phi d theta by 2. Okay, now there is no subtraction, and therefore this has okay, 1 r d phi. Again this has to be made a force r d phi. Okay, so now we have 1 differential, 2 differentials and 3 differentials, whereas for this term and this term we have 2 differentials. So we will ignore this term, and there are 2 of those. Okay, so I get n theta theta r cos phi into d phi d theta. okay, and it's in the direction negative phi. Okay, so that's what we get over here, minus n theta theta r cos phi. Okay, so time is running out. I will close here. We'll continue from the next class.